Here is the answer key for questions percent composition part 1. First problem is to calculate the percent composition of sodium oxalate. In order to calculate the percentage composition of the compound by mass, we need to know the mass of the compound represented by the formula, or its molar mass, or it could also be the formula mass in atomic mass units. We're going to use molar mass exclusively through this calculation. So our formula is Na2C2O4 for sodium oxalate. That means we have 2 moles sodium, 2 moles carbon, and 4 moles oxygen. The 3 significant figures, every 1 mole of sodium is 23 grams. Every 1 mole of carbon is 12 grams. And every 1 mole of oxygen is 16 grams. This gives 46 grams of sodium, 24 grams carbon, and 64 grams oxygen. This totals to 134 grams per mole of sodium oxalate. Now, in order to determine the percentage composition, we want to know the percent sodium, the percent carbon, and the percent of oxygen in the compound. To get the percentage, we're going to take the mass of the part we're interested in, which would be the mass of sodium, divided by the mass of the whole compound, Na2CO3, C2O4, excuse me. I'm doing oxalate, not carbonate, and then multiply that quotient times 100. This would be mass of sodium, mass contributed by sodium would be 46 grams. That's from here, divided by 134 grams times 100. So 46 divided by 134 multiplied by 100 gives us 34.3%. Okay, so again, this comes from 2 times the mass of sodium. The reason for that 2 is because we have Na2C2O4. So following that, so the 2 times the mass of sodium, or 2 times 23, which gives us our 46, divided by the mass of the entire compound, is going to give us the parts of sodium per entire compound. Okay, so our percent carbon is going to be 2 times the mass of carbon divided by the mass of Na2C2O4 times 100. This is going to be 24 grams divided by 134 grams times 100. This comes to 17.9% carbon, 34.3% sodium. And then for the percent of oxygen, we have 4 times the mass of oxygen divided by the mass of Na2C2O4 times 100. That's going to give 4 times the mass of oxygen would be 4 times 16, or 64 grams. Again, divided by the same whole, 134 grams times 100. 64 134 divided by 134 multiplied by 100 is 47.8%. And that would be oxygen. To check our answer, we add the percentages together. This comes to 100%. And all of your answers, when you add the percentages, if it's the entire compound, should add to very, very close to 100. And there may be a slight difference due to rounding at the individual percentages. Okay, let's calculate the percent composition of aluminum oxide. So we need our formula for aluminum oxide. That's Al2O3. Our mass for this, our molar mass for this, is going to be 2 moles of aluminum multiplied by 27.0 grams to 3 significant digits per 1 mole. That's 54 grams from aluminum. Grams of aluminum. And then we have 3 moles oxygen multiplied by 16 grams for every 1 mole of oxygen, and that gives 48.0 grams of oxygen. So this comes to 102 grams for the compound. So our percent aluminum is going to equal 2 times the mass of aluminum divided by the mass of everything, Al2O3, times 100. And our mass of, or our percentage of oxygen, is going to be 3 times the mass of oxygen divided by the mass of Al2O3 times 100. So this comes to 2 times 27, or as we had above up here, 54. That mass, divided by 102 grams, this mass, times 100. So 54 divided by 102 and multiplied by 100 is 52.9%. For this one, we have 3 times the molar mass of oxygen, which is 16, which is this mass, 48 grams, divided by this mass, times 100, so 48 divided by 102, that's 47.1% oxygen, 52.9% aluminum. The two of them add to 100%. And then our final compound per part, the first part, is we want to know the percent composition of potassium sulfate, K2SO4. So we have 2 moles K, 1 mole sulfur, 4 moles oxygen. There's 39.1 grams for every 1 mole of potassium. There's 32.1 grams for every 1 mole of sulfur. And there's 16 grams for every 1 mole of oxygen. This comes to, canceling moles, comes to 78.2 grams potassium, 32.1 grams of sulfur, and 64.0 grams of oxygen. We add this together, 78.2 plus 32.1 plus 64 comes to 174.3 grams for the entire compound. Okay, to calculate the percentage of potassium. That's going to be 2 times the mass of potassium divided by the mass of K2SO4 times 100 is equal to 78.2 grams here, divided by 174.3 grams here, times 100. 78.2 divided by 174.3 multiplied by 100 is 44.9%. Percentage sulfur is going to be 1 times the mass of sulfur, because the formula only has 1 sulfur in it, divided by the mass K2SO4 times 100. So that's going to be 32.1 grams for sulfur divided by 174.3 grams for the entire thing times 100. So 32.1 divided by 174.3, that comes to 55.9, might as well say 56%. And then our last one, the percentage of oxygen, is going to equal 4 times the mass of oxygen divided by the mass of K2SO4 times 100. So 64 grams divided by 174.3 grams times 100. So 64 divided by 174.3 times 100, 36.7%. Now, as I add these up, I get well beyond 100%. So I've got a percentage problem here somewhere. I can see as I go back through, I check this and I see that this is correct. 78% or 78 grams is 44.9% of 174. So there's no way that 32.1 could be 56% of 174. So I'm going to check this number. So I've got 32.1 divided by 174.3, and yes, there is my mistake. This is actually 18.4% sulfur. This is potassium, and this is oxygen. So I've got, let's try these, 44.9 plus 18.4 plus 36.7, that adds up to 100%. So think about your answers sometime. Always check at the end. Could just be a simple keystroke, but when the answer does not come to 100, or at least so close that you can decide it's due to rounding, you should always go back and check and see where your mistake is. All right, so in this problem, we're going to calculate the mass of bromine in 50 grams of potassium bromide. To do this, we have to know, first of all, the formula for potassium bromide. That's KBr. And we want to know the mass of bromine that's in 50 grams of potassium bromide. So what we need to know is the percentage composition. We need to know what percentage of KBr is due to the mass of bromine. And as we find that, what we can do is we can say that we have a X percentage. We can then take that percentage of 50 grams. So, because percentage doesn't depend upon mass, percentage is a ratio. It's always going to be a constant for a compound. So our first step in this, we would need to find the molar mass of potassium bromide. So we have 1 mole potassium, and we have 1 mole bromide. Okay, our potassium, 39.1 grams per 1 mole. That's going to be 39.1 grams. And then we would have 79.9 grams of bromine. per 1 mole bromine. That's 79.9 grams. So I add these together, 39.1 plus 79.9, and that gives me 119 per molar mass. So then we're only interested in bromine this time, so our percent bromine is equal to the mass of bromine, we only have one of them, divided by the mass of KBr times 100. So percent bromine then is equal to 79.9 grams divided by 119 grams times 100. That gives 79.9 divided by 119, and then multiplied by 100 is 67.1% bromine. Okay, so here's the way we would put this problem. We have a 50-gram sample of potassium bromide. 67.1% of the 50 grams KBr is bromine by mass. So if we want to know the mass of bromine, then all we have to do is take 67.1% of 50 grams. So to do that, there are multiple ways that you could go about doing this, and it depends on how you've handled it in your math classes. I would convert the 67.1% back to a fraction. So for instance, if we do 79.9 divided by 119, you get something known as a mass fraction, which is just 0.671 in no units. Okay. If we multiply that by 100, right here, we get our 67.1%. So we can multiply our mass fraction by the 50 grams, 0.671 times 50 grams. That's taking 67.1% of 50 grams, so 0.671 times 50. And that's 33.6 grams of KBr. Another way to look at this is to say, when we look at this percentage, a percent is equal to a part per 100. The way we can say that is that if it's 67.1% bromine, then we can say that there's 67.1 grams of bromine for every 100 grams KBr. That's the same thing as saying that we say in our percentage. 67.1 per 100. That ratio has to be the same. This is a constant ratio. So, to keep the same ratio, we could say we would have X grams of bromine per 50 grams KBr. So then we solve, and just by cross multiplying, so we would have 50.0 grams KBr times 67.1 grams bromine divided by 100 grams KBr. This is just from cross multiplying, and then dividing is X grams of bromine. 50 per 100 is 1/2, so it would be 1/2 of 67.1. 0.5 times 67.1 is 33.6 X grams of bromine. Either way, we get the same answer. And there's other ways that you could see setting this up also from the standpoint of solving a percentage. Okay, so again, 33.6 grams is the answer. I'm going to have a tendency to go with the moving the decimal and solving. All right, the next problem, we want to know the mass of chromium in 1,000 grams of sodium dichromate. So, following the same problem-solving style, we've got, first of all, we need the formula for sodium dichromate. We have Na2Cr2O7 will be sodium chromate. We are interested in the percent by mass of chromium is going to be 2 times the mass of chromium divided by the mass of Na2Cr2O7. That's a 7 times 100. So two things that we need. We need the mass of chromium and we need the mass of sodium chromate. So let's speed up the finding of molar masses. We have Na2Cr2O7. We're going to say 2 times 23 for sodium plus 2 times 52 for chromium plus 7 times 16 for oxygen. So this is sodium, this is chromium, and this is oxygen. So 2 times 23 is 46, plus 2 times 52 is 104, plus 7 times 16 is 112. So 112 plus 104 plus 46, that comes to 262 grams for the entire compound. So up here we've got 2 times chromium, that's going to be 2 times 52, or 104, divided by 262, which is the mass of the entire compound, times 100. 104 divided by 262, that's 39.7 percent chromium. So then all we have to do, we're trying to find the mass of chromium in 1,000 grams of this compound. Convert this to a fraction, which is 0.397 times 1,000 grams, coming from here, and that's going to be 397 grams of chromium present in 1,000 grams of sodium dichromate. All right, next problem. We want to know the percentage water in, or did I miss one? I actually missed one here. So we're doing, calculate the mass of cobalt in 2.84 grams of cobalt-2 acetate. All right, so first we need cobalt-2 acetate. That's going to be CO, C2H3O2, 2. All right, so adding up the molar mass, we've got mass of cobalt plus 2 times, make that 4 times, excuse me, mass of cobalt plus 2 times 2, 4 times the mass of carbon, plus 2 times 3, 6 times the mass of hydrogen, plus 2 times 2 is 4 times the mass of oxygen. So mass of cobalt is 58.9. Plus 4 times 12.0 plus 6 times 1.01. These are all in grams. Plus 4 times 16.0 grams. So this is 58.9 plus 48.0 plus 6.06 plus 64.0. So that comes to 58.9 plus 48 plus 6.06 plus 64. That comes to 179.96. Which we'll just call 180.0. Okay, and that would be grams. Alright, so we need this is our molar mass, we need the percentage of cobalt is going to equal our mass of cobalt, we only have one of those, divided by mass CO2H3O22 times 100. That's going to be 58.9 coming from here, divided by 180 coming from here, the total mass, times 100. That's 58.9 divided by 180 and multiplied by 100 is 32.7% cobalt. Just highlight that. Okay, so we have 2.84 grams, so we can say that 0.327 times 2.84 grams will give us our, this is 32.7% of 2.84, and that comes to 0.929 grams of cobalt. Just less than a gram. Okay, next problem. We're going to look at hydrates. This is something that we'll be dealing with in lab soon. So we want to know the percent water in sodium carbonate, Na2CO3 decahydrate. Okay. The formula of the equation for this would be percent water, the part that we're interested in. So we would have 10 times the mass of water divided by the mass of the entire compound, Na2CO3.10H2O, times 100. So, if we've got, I'm going to come down here and add this up, we've got Na2CO3.10H2O. This dot just means that the water is electrically attracted to the crystal of sodium carbonate. It is not an indication of multiplication. So we have 2 times 23, which is the mass from the periodic table for sodium, plus 12, plus 3 times 16 plus 10, let's make that 20, times hydrogen's mass The reason for that is 10 times 2 is 20 times 1.01, which is hydrogen, plus 10 times 16.0. So this is 46 plus 12 plus 48 plus 20.20 plus 160. Now this is the Na, this is Na, this is carbon, this is oxygen, this is hydrogen, and this is oxygen again. And we could also say that this part is H2O. Alright, so let's add the whole thing up. We've got 46 plus 12 plus 48 plus 20.2 plus 160. That gives a total of 160. No, it doesn't. It gives a total of 286.2 grams. And we can say that for water, we've got 160 plus 20.2, that's going to be 180.2 grams from water. So when we come back up here and plug in, the percent water is equal to the mass of water, which is 10 times the mass of water, which is going to be 180.2 grams, divided by the mass that's here, divided by the mass of the whole thing, 286.2 grams, times 100. So 180 divided by 286.2, and that comes to, percentage-wise, multiplied by 100, you get 62.9% H2O. So with that in mind, we can calculate the mass of water in this compound, because we can say that 62.9%, or 0.629, times the mass of the entire compound, which is not that, it's up here. Actually, we are doing that. That's all we needed to do. I was going further. 62.9% is the final answer. Next problem. Calculate the percentage water in nickel 2 iodide hexahydrate. So, nickel 2 iodide is NiI2 hexahydrate .6H2O. So we want to know the percent water. That would be 6 times the mass of water divided by the mass of NiI2.6H2O times 100. So we need mass of nickel plus 2 times the mass of iodine plus 12 times the mass of hydrogen plus 6 times the mass of oxygen. Okay, mass of nickel is 58.7 plus 2 times the mass of iodine. Iodine is 127 plus 12 times the mass of hydrogen, which is 1.01 grams, plus 6 times the mass of oxygen, which is 16 grams. Okay, and we do that multiplication, add everything together. That adds to 420.8 grams. So our percentage water is going to equal, so our percentage water is going to equal 6 times the mass of water divided by the mass of the entire compound times 100. This is the mass of water right here. So from here to here, this is hydrogen, this is oxygen. So that's 12 times it's going to come to a total of 108. So that's equal to 108 grams divided by 420 grams times 100. So 108 divided by 420.8. 108, 420.8. That comes to, check that one more time. I'm going to write down what I have, 25.7% H2O. So 108, 25.7% water by mass for this compound. Now, our last problem then is to calculate the percentage of water in ammonium hexacyanoferrate 3 trihydrate. So it's a bad sounding name, but it's not that bad. Hexacyanoferrate is a polyatomic ion. Ammonium this is the formula for the whole compound. This would be the ammonium and then hexacyanoferrate 3 would be this. So the hexacyanoferrate 3 is a polyatomic ion with a charge of -3. Ammonium is here with a +1, so this is the total compound. And this is also a trihydrate, so 3H2O. So big compound. We need to get the mass for this. So I'm going to rewrite this. NH4 3 FeCN 6.3 H2O. Okay, so in putting this all together, we're going to have three nitrogens here. So this is 3 times mass of nitrogen plus 3 times 4 is 12 times the mass of hydrogen plus the mass of iron plus 6 times the mass of carbon plus 6 times the mass of some more nitrogen plus 3 times the mass of hydrogen, make that 6 times the mass of hydrogen. 3 times 2 would be 6 times the mass of hydrogen plus 3 times the mass of oxygen. So this is going to be 3 times 14 plus 12 times 1.01 plus 55.8 plus 6 times 12 plus 6 times 14 plus 6 times 1.01 plus 3 times 16 to connect all those parts. So we've got 3 times 14, 42, plus 12.12, plus 55.8, plus 72, plus 84, plus 6.06, plus 48. That totals to 319.98. Put that in, I'm going to circle that so we can keep up with it. We also need the mass of water. This represents water, hydrogen and oxygen, and this comes to 54. So our percentage water in this compound is going to be equal to the mass of water, 54 grams, divided by the mass of the entire thing, which is 319.98 grams, times 100. 54 divided by 319.98 comes to 16.9%. Water. And that concludes this answer key for the homework.